Okay, this is lesson 4.1, and our objective today is to solve and graph inequalities. Now there are four inequality symbols. We've got less than or equal to, and that's indicated by this line underneath the less than sign, greater than, and greater than or equal to. And again, the equal to's have the line underneath of the inequality symbol. In addition to knowing the symbols, you also need to know how to graph these inequalities. And I'll show you some examples of this in a minute, but notice that the less than, if you're graphing less than, you're actually going to put an open circle around the number that's the solution, and then draw an arrow to the left. And less than or equal to, you're going to close your circle in and then draw an arrow to the left. Greater than is going to be an open circle again and to the right, and then greater than or equal to will be in closed circle, and you'll also graph it to the right. So let's look at a couple of examples of graphing inequalities. In my first question here, it says that x is less than negative 3, so I want to just graph that solution. So since x does not include negative 3, it's everything less than negative 3, we're going to put an open circle around negative 3 on our number line, and then just shade everything in to the left, because x can be any number less than negative 3. So negative 4 would work, negative 5, and so on. In our second example, it says x is greater than or equal to negative 1. So the solution does include negative 1 this time because it says or equal to. So we're going to put a closed circle around negative 1. And then this time we're going to shade everything to the right, since it could be any number greater than negative 1 also. And I'm also shading in my arrow to show that even 10 would work, because any number greater than negative 1 is a solution to this inequality. Now, solving inequalities is just like solving equations, with two exceptions. The first thing is variables must be on the left side in order to graph the inequality. Otherwise, your graph is going to be backwards. And then also, if you multiply or divide by a negative number, then you have to reverse the inequality symbol. And notice that I put in capital letters that word by. So, if the number in front of x is negative and you have to divide by that number, then that's going to reverse your inequality symbol. So let's look at an example here. So looking at number 7, I've got negative 5x is less than or equal to 10. So I'm going to solve this just like it had an equal sign between it. I'm going to divide both sides by negative 5. Now here's the key here. I divided by a negative number. So I'm going to have to reverse the inequality symbol. So x, and then I'm going to reverse that around, is greater than or equal to negative 2. Then I would graph it just like I did a minute ago. I would put a closed circle around negative 2 because it has an equal to underneath of it. So it's equal to negative 2, and it's anything greater than negative 2 also. So x can be anything greater than or equal to negative 2. Now we can check these just like we checked equations. And we don't need to check every one of them, except definitely on a multiple choice test it would be a great strategy to use. So let's just pick a number that's greater than negative 2. Let's say 0, because that's greater than negative 2. And we're going to put it right back in our original inequality. So in place of x, I'm going to put 0. And I'm going to see if that's less than or equal to 10, because that was our original problem. Well, negative 5 times 0 is 0, and 0 is less than or equal to 10. Now notice that my solution, I had to turn the inequality around because I divided by negative, but when I'm checking it, I put it back in the original, and the original had a less than or equal to symbol there. Now I want to go ahead and look at number 9. So we're going to solve this just like this was an equation. And so we're going to start by distributing to get rid of our parentheses. So 8 times 4x is 32x. And then if I make this plus negative, then it's plus negative And then don't forget to distribute here. 8 times 1 is negative 8, less than or equal to. Now let's distribute the other side. 4 times 4x is 16x plus negative, and then 4 times negative 6, that's negative 24. Now we're going to move our like terms together, and remember we said we want to put our x's on the left. Our variables need to be on the left so that when we graph these, our graph won't be backwards. So I'm going to switch the 16x and the negative 8. So I've got 32x plus negative 16x is less than or equal to positive 8, because remember when I bring it over it's positive, plus negative 24. 32x plus negative 16x is 16x, less than or equal to 8 plus negative 24 is negative 16. And then I want to divide both sides by 16. Now notice here, I'm not dividing by a negative. Even though this number is negative, it's what you divide by that makes a difference. So because I'm dividing by a positive, I don't need to switch my inequality sign around. So it depends what you're dividing by that makes a difference, and that number is positive. So the solution here is x is less than or equal to negative 1. And if I graph that solution on a number line, because it has an equal to, let's say this is 0, here's negative 1, and I'm not going to go ahead and fill the rest of the numbers out, but because it has an equal to underneath the inequality symbol, I would put a closed circle around negative 1 and then graph the number line less than negative 1 to show that x can be less than negative 1. Notice that your arrow here is going the same way as your arrow here, and that makes it real important for your variable to be on the left. It makes it easier to graph. Okay, we'll also want to look at number 17. William and Deborah Pierce are celebrating their 20th anniversary by having a reception at a local reception hall. They have budgeted $3,500 for their reception. If the reception hall charges $100 cleanup fee plus $33 a person, find the greatest number of people they can invite and still stay within their budget. So I'm going to write down the numbers we're going to need. Their budget is $3,500. And they charge $100 plus $33 a person. So it's really important right here, per person, that's where your variable is going to go. Our people are going to be x. So to set up my inequality, it would look like this. So 33x plus 100, and then I've got to decide what inequality symbol to put between that and 3,500. Well, I know they can't spend more than 3,500 if that's what their budget is. So what they spend has to be less than or equal to 3,500. Then I'm just going to solve that. So I moved my 100 over and had 33x less than or equal to 3,500 plus negative 100. So 33x is less than or equal to 3,400. Now I'm going to divide both sides by 33. So when I divide, I get 103.03 repeating. So the greatest number of people that they can invite to their reception is just 103. You can't have 0.03 of a person, and I can't go over 103 because that's going to make me go over $3,500. On number 18, I want to find the values of x so that the perimeter of the rectangle is no greater than 130 centimeters. So we know that this is a rectangle, and we know that perimeter is found just by adding all the sides. So since it's a rectangle, we know that this opposite sides are equal, so that makes these two sides x and 45. So we're just going to add all the sides together, and we don't want those to be greater than 130. which means if they can't be greater than, they have to be less than. They could be equal also. So my inequality looks like this. X plus 45 plus 45 has to be less than or equal to 130. Then I'll solve the inequality. So I simplified first and added my like terms. So I've got 2x plus 90 is less than or equal to 130. Now I'll move my like terms together. So I moved my 90, and it's 130 plus negative 90, and I simplified that, and I've got 2x less than or equal to 40. Now I'll divide both sides by 2. So x has to be less than or equal to 20 in order for the perimeter to be less than or equal to 130. So the last question I want to look at is number 19. It says Ben bowled 148 and 196 in his first 2 games. What must he bowl in his third game to have an average of at least 160? Now remember to find average, that's the mean. I need to add up all the scores and divide by how many games Ben bowled. The problem is I don't know one of his scores, so I'm going to let that third game be X. So he wants his average of the first 3 games to be at least 160. Now at least means he would like it to be 160 or more. So that means we're going to use greater than or equal to in our inequality. So here's the inequality set up. I add the first 3 games, 148 plus 196 plus x, and then that sum gets divided by 3. Now notice I use parentheses because I need to do my addition before I divide by 3. And that will be greater than or equal to what he wants his average to be, which is 160. So to solve this, I'm going to get rid of my fraction by multiplying both sides of my inequality by 3. When I multiply the left side by 3, it gets rid of the fraction. And so I've got 148 plus 196 plus x is greater than or equal to, and then the right side multiplied by 3 is 480. Now I'll combine my like terms. So I add 148 and 196, and I get 344. And I'm going to move 344 over to the same side as 480, since those are like terms. Remembering to change the sign, it will be negative. So 480 plus negative 344 is 136. So Ben will need to score 136 in his third game in order for the average of those 3 games to be at least 160. So do your 4.1 homework, numbers 1 through 25. Remember that by tomorrow you need to have at least 80% finished in order to listen to music tomorrow. You may listen to music today. Remember, at least means greater than or equal to 80%.